Hello everyone, welcome to the Langomaga channel. I am Langomaga and I invite you to questions and answers session. I invite you to ask questions and I will be answer on these questions. Sorry. Okay, guys. Which questions do you have? Oops, sorry. I will be wait for your questions. How are you today? Nice, where are you? What would you talking about? Hmm? Okay, guys, so let's read some articles in English. NASA's James Webb Space Telescope may have discovered tentative evidence of a sign of life on a faraway planet. It may have detected a molecule called dimethyl sulfide. On Earth, at least, this is only produced by life. The researchers stress that the detection on the planet 120 light years away is not robust, and more data is needed to confirm its presence. Caution. But Prof. Matt Hudson, Husudan, described the detection of DMS as tentative and said that more data would be needed to confirm its presence. Those results are expected in a year. If confirmed, it would be a huge deal, and I feel a responsibility to get this right if we are making such a big claim. Sorry. It is the first time astronomers have detected the possibility of DMS in a planet orbiting a distant star. But they are treating the results with caution, noting that a claim made in 2020 about the presence of another molecule called photosyn that could be produced by living organisms. In the clouds of Venus was spotted a year later. Even so, Dr. Robert Massey, who is independent of the research and deputy director of the Royal Astronomical Society in London, said he was excited by the results. We are slowly moving towards the point where we'll be able to answer that big question as to whether we are alone in the universe or not, he said. I am optimistic that we will one day find signs of life. Perhaps it will be this. Perhaps in 10 or even 50 years we will have evidence that is so compelling that it is the best explanation. JWST is able to analyze the light that passes through the faraway planet's atmosphere. That light contains the chemical signature of molecules in its atmosphere. The details... Cześć. Dobra, kobra, odpuść sobie. The details can be deciphered by splitting the lights into its constituent frequencies, rather like a prism creating a rainbow spectrum. If parts of the resulting spectrum are missing, it has been absorbed by chemicals in the planet's atmosphere, enabling researchers to discover its composition. The feat is all the more remarkable because the planet is more than 1.1 million billion kilometers away. So the amount of light reaching the space telescope is tiny. As well as DMS, the spectral analysis detected an abundance of the gases methane and carbon dioxide with a good degree of confidence. The proportions of CO2 and methane are consistent with there being a water ocean underneath a hydrogen-rich atmosphere. NASA's Hubble telescope had detected the presence of water vapor previously, which is why the planet, which has been named K2-18b, was one of the first to be investigated by the vastly more powerful JWST, but the possibility of an ocean is a big step forward. A recipe for life. The ability of a planet to support life depends on its temperature, the presence of carbon, and probably liquid water. Observations from JWST seem to suggest that K2-18b ticks all those boxes, but just because a planet has the potential to support life, it doesn't mean that it does, which is why the possible presence of DMS is so tantalizing. What makes the planet even more intriguing is that it is not like the Earth-like, so-called rocky planets discovered orbiting distant stars that are candidates for life. K2-18b is nearly 99 times the size of Earth. Exoplanets, which are planets orbiting other stars, which have size between those of Earth and Neptune, are unlike anything in our solar system. This means that these sub-Neptunes are poorly understood, as is the nature of their atmospheres, according to Dr. Sub Hyde Sarkar of Cardiff University, who is another member of the analysis team. Although this kind of planet doesn't exist in our solar system. Sub-Neptunes are the most common type of planet known so far in the galaxy, he said. We have obtained the most detailed spectrum of a habitable zone sub-Neptune to date, and this allowed us to work out the molecules that exist in its atmosphere. Follow Palap on X, formerly known as Twitter. Okay, guys. Let's continue. Will the Gulf Stream really collapse by 2025? The Gulf Stream system of warm ocean currents could collapse as early as 2025, a scientific study has warned. The end of the sea system, which drives the Atlantic's currents and determines Western Europe's weather, would likely lead to lower temperatures and catastrophic climate impacts. But leading scientists have reservations about the study and say it is not established science. It is far from certain the system will shut down this century, they say. The most recent assessment by the Intergovernmental Panel on Climate Change conclude that the system known as the Atlantic Meridional Overturning Circulation (AMOC) would not collapse as quickly as the study has suggested. The study's author, Prof. Peter Ditolfsen at the University of Copenhagen, told BBC News that other scientists had warned about the potential collapse of the AMOC. There's been worries that this current is weakening for as long as we have had measurements of it since 2004, he said. The AMOC is a complicated set of currents that bring warm water north towards the pole, where it cools and sinks. But as global temperatures rise with global warming, fresh water is pouring into the AMOC from the melting Greenland ice cap and other sources. If it collapses, it could lower temperatures by up to 10 or 15 degrees in Europe and lead to rising sea levels in the eastern US. It would also disrupt rain that billions rely off for agriculture. The last time AMOC stopped and restarted was during the ice ages about 100,000 to 12,000 years ago. The new study, published in Nature Communications, used sea surface temperature data stretching back to 1870 as a way of assessing the change in strength of AMOC currents over time. It estimates AMOC could collapse between 2025 and 2095. The analysis is based on greenhouse gas emissions rising in the same way as they have done thus far. If emissions start to reduce, the world would have more time to keep temperatures below the point at which AMOC would potentially collapse. Skepticism. However, scientists including Ben Booth and the Met Office Hadley Center say the paper's conclusions are far from settled science. We just don't have the evidence to state that it has declined, says Prof. Penny Holiday at the National Oceanography Center. We know that there is a possibility that amok could stop what it's doing now at same point, but it's really hard to have certainty about that. She says, if my neighbor asked me if I should worry about heat waves of the amok collapse, I would say worry about temperatures. We know that is already happening and will get worse, she said. The reasons for many scientists' reservations is that they say the study's authors made a series of assumptions about how to understand amok. But the climate system is extremely complex and experts do not have all the evidence they need to fully understand amok. The predictions that it could collapse as early as 2025 or by 2095 should be taken with a large grain of salt, says John Robson at the National Center of Atmospheric Science, University of Reading. But it doesn't mean that the study is not important or that the possibility of amok shutting down should be dismissed, they say. We do still have to take the idea seriously that there could be abrupt changes in the North Atlantic climate system, says Prof. Robson. But the exact predictions that it will happen, and within this time frame, you have to take that with some skepticism, he adds. Okay, guys. I will be back in a few minutes. Thank you, Bourgeois. I don't know what you want. Okay, thank you. Okay. I will wait for you. Okay, guys, let's continue. Robots are trained to help revive coral reefs. It's a really special part of the world, says marine biologist Tyrion Foster from the Abrolhos Island. "40 miles from the coast of Western Australia. There are no palm trees or luscious vegetation, but once you get in the water, you see all these tropical species of coral and fish. Corals are animals called polyps, found mostly in tropical waters. The soft-bodied polyp forms a hard outer shell by extracting calcium carbonate from the sea. Over time, those hard shells build up to form the foundations of the reefs we see today. Coral reefs may only cover 0.2% of the seafloor, but they provide a habitat to more than a quarter of marine species. However, the creatures are sensitive to heat and acidification, so in recent years, as the oceans have warmed and become more acidic, corals have become vulnerable to disease and death. According to the Global Coral Reef Monitoring Network, a 1.5°C increase in water temperature could see losses of between 70% and 90% of the world's reefs. Some scientists think that by 2070 they will be gone altogether. Climate change is the most significant threat to coral reefs around the world, says Kathy Page from the Australian Institute of Marine Sciences. AIMS. Severe bleaching events caused by climate change can have very negative effects. Mr. Page continues, and we don't have good solutions yet. Coral restoration efforts usually involve transplanting tiny corals cultivated in nurseries onto damaged reefs. However, the work can be slow and costly, and only a fraction of the reefs at risk are getting help. In the shallow waters of the Abrolhos Island, Mr. Foster is testing a system she hopes will revive reefs more quickly. It involves grafting coral fragments into small blocks, which are inserted into a molded base. Those bases are then placed in batches on the seabed. Mr. Foster designed the base, which is shaped like a flat disc with grooves, and a handle, and is made from a limestone type concrete. We wanted it to be something we could mass produce at a reasonable price, explains Mr. Foster. Miss Foster. And easy for a diver or a remotely operated vehicle to deploy. So far, the results have been encouraging. We've deployed several different prototypes of our coral skeletons, and we've also tested this on 4 different species, she explains. They're all growing wonderfully. We're bypassing several years of calcification growth that it takes to get to the base size, she says. Miss Foster has formed a start-up firm called Coral Maker and hopes that a partnership with San Francisco-based engineering software firm Autodesk will accelerate the process further. Their researchers have been training an artificial intelligence to control collaborative robots, cobots, which work closely alongside humans. Some of these processes in coral propagation are just repetitive pick and place tasks, and they're ideally suited to robotic automation, says Ms. Foster. A robotic arm can graft or glue coral fragments to the seed blocks. Another places them in the base using vision systems to make decisions about how to grab it. Every piece of coral is different. Even within the same species. So the robots need to recognize coral fragments and how to handle them, says Nick Carey, Senior Principal Research Scientist at Autodesk. So far, they are very good at handling and the variability in coral shapes. The next step is to move the robots out of the lab, which Mrs. Foster says should be happen in the next 12-18 months. However, the real world presents many changes. Wet, living coral needs to be handled delicately, possibly on a moving boat, and salt water is potentially damaging to electronics. We need to ensure we can shield the more vulnerable components, says Ms. Carey. There's also the high cost of such technology. Coral Maker is betting on demand from the tourism industry and plus plans to issue biodiversity biodiversity credits, which work similarly to carbon credits to stay ahead of the curve and enable coral reefs to survive. A warming future requires a substantial investment of time, money, and human capital, says AIMS scientist Katie Page. Okay, guys, and that's all for today. So thank you very much, and see you next time. Bye bye.